This is part 4 extended. Some issues that you might come across is that you'll run out of space on the graph, or you're not able to get your PID constants to fit all the different movements. So to help fix that is you can come over to the test turn function and you can comment out stuff that you don't want to tune yet. So in this video that you'll see, I've had issues tuning the turn to angle only 5 degrees, as I needed an integral term to get it up to the 5-degree mark, but having the integral term made it much harder for me to tune my PD constants. And then also, if you need more room in the graph though, you can scroll down all the way until you get to config tune heading, config tune turn, there we go, because I'm tuning the turn PID, and then you can change the time spent graphing in milliseconds to something like 15 seconds, for example. Okay, first I start the program and then press tune relative, then press tune turn. So the first step is to increase KP until it starts to oscillate. So I'm using the default constants as a guide, and they set it around to 0.4. So I am getting some oscillations for sure. But as you can see, my graph isn't showing all the data, so I would want to extend the graph or remove a piece of the turn motion. So still some good oscillation. Reduce KP down by a little bit. I'm reducing turn timeout so I can get more space on the graph. Timeout means that after 1 second now, it'll automatically move to the next drive motion, next turn motion. So I'm getting a tiny bit, but not really oscillation. But maybe I'd want to increase KP by a tiny bit. I think that'd be good oscillation to start turning up the D now. So that's how you know when you've added a little too much D, is when the robot stops before the set point and then slowly adjusts to it. So that's one sign that you want to decrease the D. So here's where I add integral. So I wouldn't recommend doing this just because it can make your PD tuning messy. But what I'm doing is I'm giving a start I of 15 and then increasing the I to 0.02. So it's still doing the thing where it gets to a point and then slowly settles in. It like hesitates, kind of. So yeah, you can see on the graph here, it's like getting to a point, slowing down too fast, and then settling into the set point. And so this is where you'd want to decrease your derivative or D value. So I remove the integral term. So now it's not quite reaching the set point. It's getting better. I just keep decreasing the D value. It's getting better, still in that third turn motion, still not quite reaching the set point. So this is where you could keep decreasing the D, but also look to add some integral. But that looks really good, that graph now. So I'm going to add back the integral term now to help get it to that set point now, because it's undershooting a little bit. See on that graph. So I would say that's a tuned turn PID. What it's looking like though is I should add a little bit more P and then decrease the D a little bit. As you can see, it's doing that thing where it doesn't quite reach the set point. It kind of hesitates and then slowly gets into it. But with some more tuning, I could make this better, but that'll work. And here's the finished product.